Everyone, so now we are going to talk about moving coil galvanometer. So in moving coil galvanometer, like what is a moving coil galvanometer? It is a device which we use. Galvanometer, we all know what is galvanometer, right? We use this device to measure electric current, a small amount of electric current, and usually we use this one to detect the current, to indicate the current as well. Okay, so that is what is moving coil galvanometer. So it is a device which we use to measure or which we use to indicate small amount of current or the current in an electric circuit. Okay, so what is the principle of this? If we place, principle is what we have learned in the last video, that is the principle. That is, if we place one current carrying coil in a magnetic field, rectangular coil in a magnetic field, so there will be a torque acting on that. That is what is the net torque is equal to BIA sin theta, or the maximum value is equal to BIA. So that is what is the principle of galvanometer. So again, you have to read that along with my class. I mean, you have to read that portion. I mean, the working portion and the diagram and the working portion. That is your assignment. You have to check that. Okay, it's very easy. What is the assignment? The diagram, and I'll discuss only the mathematical view of that. And diagram and working, both are very easy, and you have to check that. Okay. So if you have it out, you check the previous video and how how the torque acting, how we find out the torque acting on that. That is what is the working. Okay. So, and the setup also. Okay. And also you check this. Torque is equal to B cross F. So here one force will act on this side in this direction, and one force will act on this in this direction. So in two-dimensionally we cannot show that, but the force will be like this. Okay, so that is what is the exact case. That is the 90-degree case. I mean the maximum value case. Okay, so torque is equal to B cross F, and B into F, which is equal to B into BIL. So which is nothing but how much is L into B? L into B is nothing but the area, which is this much is L and this one is B. That is how they have taken. So in the previous case we have taken this is A and this is B. Both are okay only. And then L into B is equal to A. And torque is equal to NIAB. Torque is equal to NIAB. So this is what we have learned. What is N here? N is an extra term, which is number of turns. Number of turns. N is nothing but number of turns. And also in first year class we have learned that, especially in oscillation, you must have seen that like some of the problems we have associated with this. That is, torque is nothing but K theta. In the case of a fixed wire, and when you test that, so you can find out that torque is equal to K theta. This one we have learned it. So what is K here? K is nothing but torsional constant. Torsional constant, or what is theta K? What is K is nothing but it is the total amount of coupling. Coupling per unit twist. Coupling per unit twist. That is what is K. And what about theta? Theta is nothing but amount of twist. Amount of twist. So now you remember where we have used this, where we had used this before. That fix a rope over there, and when you rotate it, then that is what is the case. Okay, so here NIAB is equal to K theta, and I is equal to K divided by NAB into theta, or I is proportional to theta. How much is the twist? Or I is equal to G theta. So K by NAB, K divided by NAB, that is equal to G. So what is G? G is nothing but galvanometer constant, or it is nothing but the galvanometer constant. And also next term we are going to discuss current sensitivity. What is current sensitivity? Current sensitivity and voltage sensitivity. Current sensitivity is the total twist per unit current. That is what is current sensitivity. That is 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 equal to theta by I. Just from this equation only we are defining all those things. This is NAB divided by K. So Is is equal to 1 by G. So NAB divided by K by NAB, G. So NAB divided by K is equal to 1 by G. And IS, look at IS equation, current sensitivity is NAB divided by K. So here IS is proportional to N, IS is proportional to A, IS is proportional to B, inversely proportional to K. So you have to write what are the conditions of, to increase IS, current sensitivity. Increase N, increase A, increase B, decrease K. Okay. Decrease K means coupling per unit twist or torsional constant. We have to use the material with less torsional constant. Okay. So next one, voltage sensitivity. Vs is equal to theta divided by V, that is unit twist per. What is voltage sensitivity? It is nothing but unit twist per, total twist per unit voltage. So Vs is equal to theta divided by I into Rs. What is V? I into Rs. So NAB divided by K into Rg. What is Rg? Rg is galvanometer resistance. Galvanometer resistance. Okay. So Vs is equal to 1 by G into Rg. So Is divided by Rg. Okay. So here also you have to check how can we increase voltage sensitivity. So current sensitivity, voltage sensitivity, and this one. So all of you understand that, and then we have to check other important terms and things, and then figure of merit of galvanometer, that is also important. It is defined as the current which is produced a deflection on one scale of division in galvanometer. So in one scale of division, how much deflection it makes. So that is only we don't need the equation and all, only we need the definition only, and all the other things you just keep in your mind. And next we will discuss how we convert galvanometer into ammeter, or how we convert galvanometer into voltmeter. Both of them we will consider. Okay, thank you.